happy Sunday, University of Washington. We're back for Volume 3 on the SDR GQ sensor for the COVID class EEP598 for the University of Washington in fall 2020. Kevin and I will be going through how to load starting code into the sensor today. I have a couple different ones here. I was actually going to do it on my side, but I ran into some driver issues on the USB system. So Kevin's gracious and helpful enough today to kind of walk through some of the instructions on modifying simple variables in the code to actually see different results, on if statements, on while loops, etc., etc. So I'm going to walk you through loading code into the sensor here, just step by step. We'll go through the evolving lecture notes here, and as we go through the downloadable links, number one, what you guys want to do is when you come here, you have to download this link first. Now this is an assortment file. I discussed this in Volume 1 and Volume 2. This isn't 100% necessary for you to compile, but all the other code will reference these subscripts, so it needs to be in the same subfolder, which you can actually see way up here above me in this file here, okay? So all of that information needs to be in the same subfolder. Very, very important. So once you download that, you're going to go to link number 2. This file is the application that is able to download the chosen hex file that you'll actually compile in the C51 compiler, and then you're going to upload it to the sensor. It's very painless once you have everything set up, and then you'll need to modify this from .ex to .exe in order to enable full functionality. And then on step number 3, we're going to have this right here, and this is the C51 Keel compiler. This is mandatory. You need this. This is going to upload that project file number 3 that we submitted to you, and then you can modify this in project 4, project 5, project 6 as you continue to modify for your final project, okay? Now, when you're coming down here for the procedure on this individual system, as I stated before, all of these systems need to be in the same subfolder. So you'll have that user UW demo SDC-ISP-15XS-F or v6.87l.exe. That's that file that you want to rename to exe. And then you'll have the test3.uv project file. That's the new project file that we're sending to you as a modification of the original code from the manufacturer, so we'll no longer have that functionality once you upload this new code to the sensor. It's very important for you to understand. And then again, you'll see at that bottom that UW demo zip, which is the precursor to the UW demo file you see above it, which has been extracted. Okay, so as we walk through this file system, this is very simple. You're going to double click on that test3.uv project file. And this should automatically open your Keel Vision 5 compiler after you've installed it. Okay. Now there's an error that immediately pops up. This doesn't preclude you from using the sensor. Once you get into this other program that allows you to upload it, you'll see that USB connection over 115,200 baud. Okay. So don't worry about that. What you need to do is navigate to the main.c file, and when you get to that main C file, you just double click on it, and then what we'll do from there is we're going to double click on the rebuild button. Now this rebuild button is the third button from the left, and Kevin will show this in real time as we step through modifying the code and changing some variables on distance and color and tone and vibration. So once we have everything there, you're going to modify, you're going to click that rebuild button, and once you have that rebuild button, if you look above me, you're going to see a few additional files, I2C, interrupt, and main, and then you'll see something above that, which is actually the object folder. In that object folder is the hex file that you'll need to upload once we get to the part of the instructions, okay? So now that we've modified that code, you're going to see the I2C.lst, interrupt, and main. You're going to check inside that object folder to make sure the SDROA.hex file is available and present. Okay, so once you have that file there, you're going to open the stc-isp-15cc-v6.87l.exe file. Okay, and once that opens, then you're going to navigate to the, there we go, perfect. So you're going to have to modify the MCU type. Okay, it's very, very important that you modify the MCU type on this system, and then once you modify the STU type on the system, you have to select STC, which is 8F2K16S2, and you have to change the input frequency to 11.0592. And once you connect the USB port will initialize on channel 340 on a COM from 2400 to 115 200 baud rate. So we're just going to walk through that really quick. And now on Kevin's side, we're going to actually go through this in real time so you guys can see how to modify the code and how that looks like when you start to go into the C strip and then rebuild it, recompile, get the hex file, and then go from there. So Kevin, we're going to jump over to you now, and we're going to make sure that you've got everything set up, and he does. And what we see here in this C file that we're looking at on Kevin's side is everything opened up per that step-by-step evolving lecture notes. And you see this right here. This is the Keel C51 compiler, and he's on line 89. So line 89 is very important because this is the if range statements. So this is essentially where you have if range in feet is less than 6 feet, we're going to set the LED to 3. And then on line 90, else if range is less than 7 feet, we'll set the LED to number 2, which is blue, right, Kevin? And then
Yes.
on 91, we'll set else if range in feet is less than 8 feet, set LED to 1, which is green, else set LED to 0, which is off. So this is where you can change the colors, you can change the distance measurements, you can do a lot of modifications here. And this is very important because this is what the sensor is made for, right? It's a vertical cavity surface emitting laser at around 860 nanometers, and it's sending out that laser, that photon at the speed of light, 10 times 8, essentially 2.98 times 10 to the 8, and then it's going to measure the time of flight. It's going to measure the distance that from this reference point, sending it out to an object, and the time in milliseconds all the way back to the sensor. And that's how we know how far an object is from the reference point of the sensor. Okay, so he's going to change this from 3. Kevin, you can change this to whatever you like, but we want to modify it from this reference point. So 3 is saying if it's less than 6 feet, we want to turn it red. But we want to modify this. So Kevin, what he wants to do here is if it's less than 6 feet, maybe we turn it blue. So we'll set it from 3 to 2.
All right, so here we just changed one single digit. That should tell it that when it's less than, it detects an object within 6 feet, the LED on the sensor should display blue. So at the moment, the sensor that we have right now programmed, it is displaying red. If you can see it in the LED, yes. So here we are going to rebuild this and compile it and create a new hex file. From here, we're going to open this file that was just compiled and make sure the settings are all adjusted accordingly. And now, assuming that you have the adapter and the sensor plugged into your computer, it should download perfectly. And now it should adapt a new function. So whenever I'm putting this in front of my laptop right now, which is within 6 feet, and it is displaying a blue light on the LED, which is exactly what we changed here.
Fantastic, Kevin. Well done, sir. And now what we want to modify, again, you can go down there and change a few other parameters on different LEDs, but what we want to do now is come down to this vibration function. Basically, it's to hold the key to trigger vibrate. So if something is detected within 6 feet or 7 feet or 8 feet on the if statements above, this, while holding the key, will vibrate. Now on line 111 and 112, it's just turning it on. But if you go to line 114, this is a delay. What this delay represents is when you press the button and an object is detected, how long it will take for it to vibrate. So right now it's set to 1 second. And what we want to do is change that to 5 seconds. So Kevin's going to change that from 1,000 to 5,000. And then he's going to rebuild and recompile and upload this back to the sensor. And we should see a significant delay on the sensor as it is reading those input parameters accordingly.
Yeah, so currently, if I hold this middle button right now, there will be a 1 second delay before you hear vibrate. So we just rebuilt and compiled this hex file. We're going to open up this new hex file, and once again, I'm going to download it onto my sensor. And now, if you hold it, there will be a 5 second delay before it vibrates. So that's just an example of what you can be. You don't have to set this to 5 seconds. It could be any digit you really want, and it'll adjust accordingly.
Absolutely. I mean, if you wanted it less than 1 second, I mean, that's essentially 1 second or 1,000 milliseconds. You can modify that accordingly. It's all of this is the whole premise of us showing you how to modify very simple input parameters and methods is for you to understand how to develop your own application. It doesn't have to be advanced. It can be extremely simple, as this is a simple $20 time of flight sensor. But you can definitely do some really amazing things. And I've been working on this, setting up 3 to 5 to 10 different sensors as an array. Imagine that, almost like a LiDAR system. So there's a lot of things you can do with this particular product and device. And what Kevin and I wanted to show you today was just how to set it up, how each one of these screens actually look when you have it configured properly, and then how long it takes to upload code. This is a quick iterative process. So you should be able to change code and test very quickly as you keep going forward and develop new applications. And again, we want you to use your imaginative prowess. We want you to come up with something, we want you to use your ingenuity to develop something that no one else has thought of yet. So please, dive through this code. If you have any questions, reach out to Kevin, reach out to me, and we'll endeavor to help you to the best of our ability. Thank you so much for tuning in today, and you guys have a wonderful evening.